going to start with the detailed drawing or the disassembly of a drill jig. Now we will see what is a drill jig. Now this is the question of a drill jig. You can see this is the pictorial view of assembly of drill jig. Now a jig is a device which is used to hold a workpiece as well as to guide the cutting tool to perform different operations on a workpiece. So here the drill jig is used to locate the workpiece or to hold the workpiece on which the drilling operation has to be performed, as well as to guide the drill in order to make the holes inside the workpiece. Now you can see these holes which are provided here on the jig plate. This part is the jig plate. The holes are provided on the jig plate. So these holes will be used to guide the drill tool. So the drill tool will pass through these holes, and the workpiece which will be located below this plate, that is below the jig plate, on which we will perform the drilling operations. So basically drill jig is used to hold the workpiece in a proper location as well as to guide the drill tool in order to make the holes on the workpiece. Now we will see the different parts of the drill jig assembly. So the different parts are: the first part at the bottom is the base plate. The second part, that is the vertical cylindrical part, here is the stem. Now the base plate and the stem are locked with each other using the locking screw or the cap screw. So this is the cap screw. So the cap screw will be used to lock the stem with the base. Now the third part is the jig plate. Now this jig plate is having multiple circular holes in it. You can see first hole is here, second hole is here, third is hole is here, and fourth hole is here. Similarly, two holes will be present on the front side also. So in all we will have total 6 holes. Now this jig plate is fitted inside the stem. So there will be a hole at the center of the jig plate, and through this hole this stem will pass. Now we are locking the stem with the jig plate by using a latch washer and a screw. So this latch washer and this screw are used to lock the jig plate with the stem, and the jig plate is having bush inside the holes present inside it. So this bush will guide the drill tool towards the workpiece. So the different parts were the base plate and the stem, which were locked together by using a cap screw. Then the next part was the jig plate. The jig plate is locked with the stem using a latch washer and a screw. And the final part, that is the holes inside the jig plate, will have bushes inside it to guide the drill tool so as to make drilling holes inside the workpiece. So basically drill jig is used in mass production where a multiple number of holes has to be drilled or to be made in the workpiece in a less time number, in a shorter time. So whenever we need mass production, we will use the drill jig. Now you can see here the individual drawing of each and every part is given. So here there is a cap screw. This is the cap screw which is used to lock the stem with the base plate. This is the base plate. Now the base plate is having holes with threading inside present inside it. Now these holes are provided so that this cap screw can pass through these holes. And finally, when the cap screw is inserted through this hole, this cap of the screw will rest at the bottom, whereas the threaded part will pass through this hole. The some part of the screw will go inside the stem. You can see a threading is provided inside the hole which is present inside the stem. So some part of the screw will go inside the stem, and finally what will happen, the stem will get locked with the base plate. Now these holes are present in three quantity or three numbers. You can see at the bottom, this is the entire view, whereas the sectional front view, we have taken half section. So this is the sectional front view of the stem, whereas this is the entire view of the part. Now this part is having three holes at the bottom. You can see first hole, second hole, and third hole. So these three holes are provided at the bottom of the stem, and similar holes will be provided at the top portion of the base plate, that is inside this hole. So this hole will also have, or this slot will also have three holes inside it, and the diameter of this hole and this hole will be same, so that when we will insert these screws through the base plate, they will get locked by passing through the base plate and into the stem. So they will lock the stem with the base plate. Now this is the jig plate. Now jig plate is having holes inside it. You can see first hole, second hole, third hole, and fourth hole. The total number of holes present is what? 6 holes. But since we have taken the half section, so here we can see only 4 holes. And also there is a hole at the center. This hole is provided so that we can insert this stem through this hole. And inside these holes we will insert the bushes. So you can see these are the bushes. These bushes will be inserted inside the holes which are present inside the jig plate. Now after inserting this stem through this hole, we will lock the stem with the jig plate by using the latch washer. So this is a washer which is used to lock the jig plate as well as the stem. So when this part will get inserted here, we will lock this part and this part by using the screw and the latch washer, as well as there is a nut provided so that after inserting the stud here, we will insert a stud here. After inserting the stud here, we will lock the latch washer, the jig plate and the stem. So these were the assembly and detailed drawing. This is the detailed drawing of each and every part, or the detailed 3D view of each and every part of the drill jig, and this was the assembled 3D view of each and every part. Now we will see the assembly drawing. Now this is the assembly drawing of the drill jig. Now you can see here the top view. If you see here the top view is circles. Majority of the figures in the top view are in the form of circles. So we can conclude that these parts which are shown in the front view are cylindrical in nature. So each and every part will be cylindrical. That is, if we observe these parts from the top view, they will be observed as a circles. Now you can see the total number of holes, that is these holes which were present inside the jig plate is equal to 6. You can count here 1, 2, 3, 4, 5 and 6. So the total number of holes which are present inside the jig plate is equal to 6. Now we will see here the assembly diagram of the jig plate. Now you can see part number 1. Here the part list is given. So part number 1 is the base plate. Material is cast iron and its quantity is 1. Part number 2 is the locating peg. Material is mild steel, quantity is 1. So here different parts which are used in the assembly along with their material and the quantity in which they are present is given. So you can see here the bushes which were present inside the jig plate, or which will be inserted inside the hole of the jig plate, is made up of CS, and the quantity is 6. So we can conclude here that 6 holes are present inside the jig plate. So there will be 6 bushes which will be inserted inside this jig plate. This is the top view of the latch washer. This is the top view of the bushes, the circles, and are represented top view of the holes as well as the bush. Then this is the top view of the latch washer. Then this is the top view of the hexagonal nut which will be used to lock the stem with the jig plate. Then this is the top view of the screw, locking screw. Then this is the top view. The circles are nothing but the top view of the jig plate. Now we will here see the front view. So the part number 1, part number 2, so each and every part has been named. You have to study the question carefully. In question they will ask to draw the front view and top view only of few selected parts. So if in the exam they ask you to draw the front view and top view of the base plate or locating peg or jig plate, first we have to locate these parts in the drawing appropriately. So you can see the first part, that is the arrow pointing here towards the first part, and the first part will be what? The base plate. So this first part is nothing but the base plate. So here the entire sectional front view of the drill jig has been given. Now we have to disassemble each and every part, that is we have to separate each and every part and then draw the sectional front view and top view of each and every part with dimensions. So we will draw the first part, that is the base plate. So the first part is the base plate and its quantity is 1. So this is the base plate. Now in order to draw the base plate, first we have to identify the dimensions of the base plate. Now we will see here the dimensions. You can see the outer diameter of this base plate. This is the base plate. So the diameter of this part is equal to 190. So this part is cylindrical because here we have given the dimension as diameter 5. So 5 190 indicates that this part will be what? Cylindrical in nature. So the outer diameter or the largest diameter is equal to 190. Then the diameter of this part from here to here, that is this part from here to here, is equal to 140. Whereas the diameter of the hole which is provided inside the base plate, where the stem will be inserted. This is a stem, so the stem will be inserted inside the base plate. So the diameter of the hole inside which the stem will be inserted is equal to 76. So the three diameters identified are: first is the largest diameter or the diameter of the base equal to 190 mm. Then the diameter of this part, upper part, from here to here will be equal to 140 mm, and the diameter of the hole which is provided to insert the stem inside the base plate is equal to 76 mm. Now we will find the height of this base plate. The total height of the base plate is equal to 50. You can see here the total height of the base plate from here to here is equal to 50 mm, whereas the height of this part from here to here is equal to 25. So this height will be equal to 25, it is from here to here, and the upper height from here to here will also be equal to 25. 50 minus 25. Then the height of this hole which is provided inside the base plate will be equal to 6 mm. Now how it has came to be 6 mm, you can see here the total height from here to here is equal to 50 mm, 50 mm, whereas the height from this part up till here, that is the where the hole begins, is equal to 44 mm. So total height is from here to here is equal to 50 mm. Total height is equal to 50 mm, whereas the height from this point to the bottom is equal to 44 mm. So the height of this hole which is provided at the top of the base plate will be equal to 50 minus 44, that is 66 mm. Now you can see here that at these corners, that is at these points, the corners have been removed by using fillet. So here the corners have been removed by making fillets. And what is the dimension of this fillet or the chamfer? You can say this is a chamfer. Now chamfers are provided in order to eliminate the sharp corners. So in order to eliminate the sharp corners or the sharp edges, we provide chamfer. So the dimension of this chamfer is provided as 3 into 45 degree. That is, the height of this chamfer will be 3 and the inclination of this chamfer line will be equal to 45 degree. So now we will draw the front view and top view of this base plate. So first we will draw a line. Now the outer diameter as given in the question, now the major diameter was equal to 190 mm. So first we will draw a line of length 190 mm. So I am drawing a line of length 190 mm. Now you can see this line will be of length 190 mm. So we have drawn first a line of length 190 mm. This line represents the base, which is equal to diameter 190 mm. Now in the next step we will mark the center of this part. So first we will draw the center line. Now we will draw the center line. So the center line will be passing through the center of this line. So this is the center midpoint. You can see this is the midpoint. Now from this midpoint I will draw the vertical center line. Now in the next step we have to draw this vertical line. Now this vertical line will be of length 25 mm. You can see the length is what, 25 mm. So now we will draw a straight vertical line from the left end as well as from the right end, which will be of length 25 mm. So from this point we will draw a vertical line of length 25 mm. Similarly from the right hand side we will draw a vertical line of length 25 mm. Now we will give the dimension. So you can see the length is what, equal to 25. Again here the dimension, the length will be equal to 25 degree length will be equal to 25 mm. So you can see the length of the line on the left hand side as well as on the right hand side is equal to 25 mm. Now in the next step we have to draw this line. Till now we have drawn the vertical line of length 25 mm. Now we have to draw this horizontal line. Now we have to find the dimension of this horizontal line. Now how can we find a dimension? Now you can see the total outer diameter is equal to 190, whereas the diameter of this portion from this point to this point is equal to 140. So the difference of 190 and 140 will be equal to 50 mm. So now this 50 has to be divided by 2 because we have the line on the left hand side also and we have line on the right hand side also. So first we will take the difference of this outer diameter 190 and the diameter of portion from here to here, which is equal to 140. So the difference will be equal to 50 mm. Now we will divide this 50 mm by 2. So we will get 25 mm. So the length of this line will be equal to 25 mm. So now we will draw a line of length 25 mm from here. Similarly, again we will draw a line of length 25 mm from this point. Now you can see I will give the dimension here. So you can see the dimension is 25 mm. So you have to draw a line of length 25 mm both on left hand side as well as on right hand side. Now we will give the dimension here. So you can see this is 25 and this is 25. Now in the next step what we have to do, we have to draw this vertical line. Now this vertical line will be of height 25 mm. The total height is 50 mm and this is also 25 mm. So the difference will be equal to 50 minus 25, that is 25. So this line will be of length height 25 mm. So now we will draw a line of length 25 mm vertical line from this point, 25 mm both on left hand side and 25 mm on right hand side. So you can see we have drawn a line of 25 mm on left hand side as well as right hand side. Now we will give the dimension. So this is 25. You can see we have drawn a line of height 25 mm and from this point we will again draw a line of height 25 mm. So first we have drawn vertical line 25 mm, then we have drawn horizontal line of length 25 mm, and then finally we have again drawn vertical line of length 25, height 25 mm. Now I am deleting this dimension. We can give it later on. Now in the next step, we have to draw this horizontal line from here to here. So we have to find the dimension of this horizontal line which is on the left hand side, as well as the same horizontal line has to be drawn on the right hand side also. So these horizontal lines, now in order to find the dimension of this horizontal line, we have to look the dimensions first. The total dimension from here to here is equal to 140 mm, whereas the dimension of the hole which is present inside the base plate at the top, that is this hole, is equal to 76 mm. So the diameter from here to here is equal to 140 mm, whereas the diameter of this hole is equal to 76 mm. So we will first find the difference. So the difference will be equal to 140 minus 76, that is equal to 64. So the difference is equal to 64. Now we have to divide that 64 by 2. So 64 divided by 2 will be equal to 32. So the dimension of this line will be equal to 32, as well as the dimension of this line will be equal to 32 mm. So now we will draw two horizontal lines of length 32 mm both on left hand side as well as right hand side. 32. Again we will draw a line from this point which will be of dimension 32 mm. Now we will give the dimension. So this line is of length 32 mm. Again this line is of length 32 mm. So you can see we have drawn a line of length 32 mm both on left hand side and right hand side. Now we will draw the hole which is present here. Now in order to draw the hole, we will find the dimension of the hole. Now the height of this hole will be equal to 6 mm. As said earlier, the height of the hole is found out by the total height of the base plate is equal to 50, whereas the height from this line up till this point, that is where the hole begins, is equal to 44. So the difference will be equal to 50 minus 44, that is 6 mm. So the height of the hole which is present inside the base plate will be equal to 44, will be equal to 50 minus 44 equal to 6 mm. So now we will mark the height of the hole which will be equal to 6 mm. So you can see we are marking the height 6 mm. Again we will mark the height on the right hand side which will equal to 6 mm. Now we will give the dimension so that you can understand. The height of this hole is equal to 6 mm. You can see the height of the hole is equal to 6 mm. Similarly, here also the dimension will be equal to 6 mm. So you can see the height of the hole is equal to 6 mm. So we have marked the hole which is of dimension 6 mm. Now I am deleting this dimension. We can give it later on. Finally, now we will join these 2 points to represent the hole. So we are joining the first point with the second point. So you can see we have completed the some part of the front view of the base plate. Now if we want to give dimensions, we can give it later on. Now in the next step, we have to show the chamfering which is done at this corner. See, these are the corners which are formed. Now we have to eliminate these corners, and these corners are eliminated by doing chamfering. So now we will provide the chamfering. In order to provide the chamfering, we have to first see the dimension of the chamfer. So the dimension of the chamfer is given as 3 into 45. So now we will provide the chamfer. So we are providing the chamfer. So you can see we have provided this chamfer. Now this chamfer will have dimension of the vertical height will be equal to 3 mm and the angle will be equal to 45 degree. Now you can see I will give you a dimension of this chamfer. The height of this chamfer will be equal to 3 mm. You can see the height, that is from this point to this point, the vertical height will be equal to 3 mm, whereas the angle of the chamfer will be equal to 45 degree. Now I will show the angle also. Now you can see the angle is equal to 45 degree. So at this corner you have to draw a chamfer line or inclined line to show the chamfering, and this inclined line will be drawn in a vertical height of 3 mm and at an angle of 45 degree. So from this point or from the corner you have to mark a height of 3 mm in vertical below direction, and from this point you have to take an angle of 45 degree. So the chamfer will have a vertical height of 3 mm and a chamfer angle of 45 degree. Similarly, now we will show the chamfer here also. So we have given a chamfer on the left hand side also. Similarly, we will provide the chamfering or we will do the chamfering on the top corner on the left hand side as well as top corner on the right hand side. So again, we will select the first vertical line. Now we are providing a chamfer. So we have provided the chamfer here also at this corner, and now we will provide the chamfering at the right corner on the top side. So again, we will select the first vertical line. This is my first vertical line. Then so you can see here we have provided the chamfering. So all the corners have been chamfered and the dimension will be 3 into 45. That is, this line will be inclined with the vertical. This is a vertical line. So this inclined line will have an inclination of 45 degree with this vertical line, whereas the height will be equal to 3 mm. So finally we have shown the chamfering at all corners. Now in the next step we have to show this hole. Now you can see the base plate is having a hole for inserting the cap screws. Now you can see this is the cap screw. Now the base plate will have a hole for inserting the cap screw, and the total number of holes which will be present inside the base plate will be equal to 3. Now you can see this from this question, that this is the stem and this is the base plate. Now the stem is to be locked with the base plate. So for locking, we insert these cap screws, that is these cap screws, through this hole. Now you can see at this bottom portion of the stem, there are 3 holes which will be placed at an angle of 60 degree with respect to each other. So we can say that if 3 holes are present at the base of the stem, then similar 3 holes will be present inside the hole of the base plate also. That is, 3 holes will be present in this slot also. So we have to show these holes in the front view as well as top view. Now you can see, when we cut the base plate from the center, that is when we take the sectional view, only this hole is being cut. That is, this hole as well as hole which is present in front will not be cut by the section plane. So only this hole which is present at the center of the base plate which will be cut by the section plane. So we have to show this hole only in the front view, whereas in the top view we have to show all these 3 holes. Now we will show the this hole, that is hole provided for inserting the screw inside the base plate in the front view. Now in order to show this hole here, first we have to mark the center of the hole. We have to locate the center of the hole. So in order to locate the center, we will see the question. Now you can see here the center distance, that is from here, that is center of the drill jig assembly to here, is not given. So the center distance from the center of the drill jig assembly to the center of the cap screw or the hole is not given. Now we will try to identify if this dimension, that is center to center distance, is given in the top view. So if we see, this is the center of the assembly in the top view, and this center line, if projected here, is not shown anywhere. So the distance from this center to this center is not given in the front view also, and it is not given in the top view also. So this part is missing in the question, so we have to assume here a suitable data. So if in the exam also the center to center distance is not given in the front view, then we will check if this distance is given in the top view. If the distance is not given in the top view also, then we will assume a suitable distance. So this distance we are assuming as 50 mm. So total center to center distance will be equal to 50 mm. So the half distance, that is from here to here, will be equal to 25 mm. So here we will be assuming that the distance from the center line of the assembly to the center of the hole will be equal to 25 mm. So we are assuming a distance of 25 mm between two centers. So now we will draw the center line which will be at a distance of 25 mm. So from here we have to mark a distance of 25 mm, and then we will mark the center again. So this is a center line, second center line, which will be at a distance of 25 mm. Now we will give here a dimension. So the dimension from here to here is equal to 25 mm, from this point to this point. So you can see the center to center distance, this is the center of the hole through which the cap screw will be inserted, and this center is at a distance of 25 mm from the center of the base plate. So if in the exam the data is not given, you have to assume a suitable data. So we have assumed the center to center distance as 25 mm. Now we have to draw the hole here. So in order to draw the hole, first we will see the dimensions of the hole. Now you can see here the cap screw, when the screw will be inserted, the head of the screw will fit inside this hole. So this is the hole which is provided for inserting the head of the screw, where this hole is provided for the shank or the lower part of the screw. So this is hole is nothing but the hole for the head of the screw. Now if we will find the dimension of this hole, now the height of the hole is given as 10 mm. The height is given as 10 mm. You can see here the dimension is given as 10 mm. So the height of this hole which is done for fitting the head of the screw is of height 10 mm, whereas the diameter of the head is not given. And in the top view also, they have not drawn the top view of these holes. So the top view of these holes is missing in this diagram. So height is given but diameter is missing, so we will assume here suitable diameter. Now you can see the lower part of the hole is having a diameter as 6. Now here you can see the dimension is given as 3 screws, since there were 3 holes in the base plate, and also and three holes will be present in this stem. So three screws, M6 and long 50. So it means that there are three screws which will be inserted through the base plate and they will pass into the stem, and each will have the major diameter as 6. So M6 indicates the major diameter of this threaded part, which will be equal to 6, and the length is equal to 50 mm. So this length is nothing but the length from this part, that is from here to the end. So the length of the screw is equal to 50 mm. That is the total height from this line to end will be equal to 50 mm. Whereas the diameter of the threaded part, that is major diameter, will be equal to 6 mm. But the diameter of this portion where the head will sit is not given. So we will assume the diameter is equal to 10 mm. Now it is obvious that the diameter of the lower part is equal to 6. So the head will be more in diameter than the lower part. So if the lower part is having a major diameter as 6, then this diameter should be more than 6. So we are assuming the head diameter is equal to 10 mm. So the height of the head is equal to 10 mm and the diameter of the head will be equal to 10 mm. So now we will draw first the front view of the head. So from this point we have to take 5 mm towards right, and then we will mark the height. Height is equal to 10 mm. Now you can see I will give the dimension. So this distance will be equal to 5 mm, whereas this height will be equal to 10 mm. Now you can see the height of the screw head is equal to 10 mm. So we have marked the height 10 mm, whereas the diameter of the screw head will be equal to 10 mm. So we have to mark the distance of 5 mm towards left and 5 mm towards right also. So now we will draw the hole. Now we will take a distance of from here equal to 10, and then we'll complete the hole. Now you can see I will give the dimension here. This diameter of the head will be equal to 10 mm. So you can see this is the hole provided for resting the head of the screw, and this hole will have a height of 10 mm. So the height of the hole is equal to 10 mm and the diameter of the hole is equal to 10 mm. So from this center you have to mark a distance of 5 mm towards left and 5 mm towards right, and then draw two vertical lines of length height 10 mm. So finally we have completed the hole for the head of the screw. Now we will complete the hole which is provided for the lower part of the screw, that is the shank of the screw. Now the major diameter was given as 6 mm. So now if the diameter is equal to 6 mm, the radius will be equal to 3 mm. So from this center we will take a distance of 3 mm towards left, and then we will draw a vertical line till here. Similarly, from this center we will take a distance of 3 mm towards right, and then we will draw a vertical line till here. So you can see now we have drawn the hole for the lower part of the cap screw. Now we will see the dimension. The diameter was given as M6. So the major diameter is equal to 6 mm. So you can see the diameter of this part or the lower part of the hole will be equal to 6 mm. Since in the question it was given M6. Now we have to show here the internal threading also. So before showing the internal threading, we will see in which part the internal threading is present. Now you can see this hole is not having threading in entire portion. From here this hole is provided for inserting the head, so head will not have any threading, and the portion from here to here, that is some suitable length of the screw, is not having threading. So this portion is not having threading, whereas the upper part is having threading. So here we have to assume that some portion of the this hole is not having threading. So we'll mark. Now here the portion which is not having the threading is not, the height is not given, so we will assume some suitable height. You can assume this height anything. Now you have assumed a suitable height. Now this portion of the screw will not have threading present inside it, whereas this upper part will have threading. So now we have to show threading in this upper part, that is from here to here. Now the major diameter of the thread was equal to 6 mm. So here we will assume the minor diameter as equal to 4 mm. So for showing the minor diameter line, we will take a distance of 2 mm towards left, and then we'll draw a vertical line. Again from this center we will take a distance of 2 mm towards right, and then we will draw a vertical line. So you can see here we have drawn the threading inside the hole. Now the major diameter of the thread is equal to 6 mm, whereas if we want to show the minor diameter, we can see here the minor diameter is equal to 4 mm. So the major diameter of the thread is equal to 6 mm, whereas the minor diameter is equal to 4 mm. For this portion you have to assume a suitable height. So here we have assumed a height, you can see, oh it is what, 7.5. Now you can see this height, that is the height in which no threading is present, is equal to 7.5. So here you can assume any height, you can assume 8 mm also, since this dimension or the height of the hole in which there is no threading is not given. So here you can assume 8 mm also. For this case we have taken as 7.5 mm. So finally we have completed the front view of the base plate, sectional front view of the base plate. Now we have to show the section lines. Now I'm deleting some dimension, we can give it later on. Major diameter of the thread is equal to 6 mm and the minor diameter of the thread is equal to 4 mm. Now this entire portion of the base plate is a solid part. Now you can see from this figure, section line has been shown in this entire part. Section line has been shown in this entire part of the base plate except the center, because a hole was present here. So this part of the base plate present here is not a, is a solid part. So we have to show the section line inside it. So now we will show the section lines inside the solid parts. So this is a solid part, this is a solid part, this is a solid part. So finally we have shown the section line inside the solid parts. Now we can give the dimension here one by one. So now I am giving the dimension. You can see here 76. I will insert the symbol 5. So 576. Now we will give the dimension of this part. So this is equal to 140 as given in the question, 140. And the diameter of the largest part from here to here will give here, and this diameter is equal to 190 mm. Now we will mark the height of the entire part. So the height from here to here is equal to 50 mm, whereas the height of this portion from here to here is equal to 25 mm. This height from here to here is equal to 25 mm. We will give the center distance also. Distance from here to this center is equal to 25 mm. Now we will give the dimension of this diameter of the head. The diameter of the head is equal to 10 mm. You can see the diameter of this head is equal to 10 mm. Now we will give the dimension of these chamfers. Now you can see here this chamfer is of height 3 mm, whereas the chamfer angle is equal to 45 degree. So you can see this chamfer angle is equal to 45 degree. So we have given the majority of the dimensions. The chamfer is of dimensions 3 into 45. So 3 will be the vertical height and 45 is the chamfer angle. We have given the diameters, and we have mentioned the center to center distance, that is 25. We have given the diameter of this part, that is 10 mm. Now we will draw the top view of this base plate. So this is the base plate. Now we will draw the top view. Now I am writing here the name of the part. So it was the base plate. We have drawn the base plate. This is the base plate, and this was the front view of the base plate. So we will mention here the sectional front view. So this is the front view of the base plate. So we have completed the sectional front view of the base plate. Now we will draw the top view of the base plate. Now since this is a cylindrical part, this is what a cylindrical part, the top view will be circle. So in order to draw the circle, first we have to mark the center of the circles. So now we will first locate the centers of the circle. Now you can see, first we will draw the center line, vertical center line, and then we will draw a horizontal center line. So we have drawn two center lines, a vertical center line and a horizontal center line. Now the top view of this part will be circles, since this is a cylindrical part. Now the largest circle will be of diameter 190 mm. This outer part is of diameter 190 mm. And if we observe this figure from the top, we can easily see this largest diameter, that is 190 mm. So the largest circle that is we draw in the top view will be of diameter 190 mm. So now we will draw here circle. Now this circle will be of diameter 190 mm. So this circle which we have drawn here is of diameter 190 mm. That is the top view of this portion, that is 190 mm. If we want, we can give here dimension also. Later we can delete it. You can see the diameter of this circle is equal to 190 mm. Now the second circle that will be visible from the top view will be a circle of diameter 140 mm. Now this cylindrical part from here, that is this vertical line to this vertical line, is of diameter 140 mm. So if we observe this cylindrical part from the top view, we have to draw a circle of diameter 140 mm. So now we will draw a second circle of diameter 140 mm. So we have drawn here circle of diameter 140 mm. We can give the dimension here also. So you can see the diameter of this circle is equal to 140 mm. Now in the next step, we have to draw the top view of this circular hole. Now this circular hole, when observed from the top view, will be visible. You can see here the circular hole which is of diameter 76 mm. Now this circular hole which is of diameter 76 mm, when observed from the top, will be visible. So here we have to draw a dark circle which will be of diameter 76 mm. So now we will draw a circle of diameter 76 mm. Now if we give a dimension, you can see here this diameter will be equal to 76 mm. So the outer circle is of diameter 190 mm, that is this circle. The second circle which is of diameter 140 mm is drawn here, this circle, and the third circle which will be the top view of this hole of diameter 76 mm is drawn here. So we have drawn three holes, three circles for the top view of the parts. Now I am deleting this dimension. Since these dimensions were already given in the front view, we don't need to give the dimension again in the top view. Now if you observe, this corner has been removed by doing a chamfering. So we can say that one circle will be of diameter 190 mm, that will be ending here, and due to chamfering, another circle, or from the top view we can again observe a circle because chamfering has been done here. So this corner, the total distance from this corner to this corner, if observed from the top view, will be observed as a circle. So we have to draw two circles in the top view, one circle for to represent this corner point, and the other circle will be drawn to represent this corner point. So wherever there is chamfering has been done or chamfer has been provided, we have to draw additional circles. First circle, that is was of diameter 190, has been already been drawn. Now we will draw the circle for this corner. Similarly, again at the top chamfering has been done, so we will again draw a circle for this corner. Now in order to draw the circles for the two ends, now we have to find the dimension of this end, that is the dimension from the center line to this point. So instead of finding a dimension, what we can do, we can directly project this point in the top view. Now you can see I will project. Now I am projecting this point, that is this point, in the top view. Now we will project the point, that is we will directly project this point. So you can see here what I have did, I have projected this end point, that is this point. Okay, it is wrong. We will project this point. Okay, we will project this point in the downward direction. So you can see we have projected the corner point. Again, we will project the second point, this point, in the top view. Now we will project this point in the top view. So this is the second point that has been projected. So you can see we have projected the ends of this chamfer line, that is the end, this is the end of the first chamfer line, and this was the end of the second chamfer line. So we have projected these two ends in the top view. Now what we can do, we know the diameter of the first circle, or the end of the first circle will be at this point, and the end of the second circle will be at this point. So now we will draw circles directly. So taking this as a center and this point as the radius, we have drawn the first circle. This will be the center, and this point will be the, so this is the center, and this point will be the end radius. So we have drawn the first circle. Again, by taking this point at the center, and second point will be this point where the line is projected, this will be my second point. So we have drawn two additional circles, this circle first, and the second circle was drawn here to represent the chamfer circles. Now we will delete these lines. So you can see here, in total we have drawn 5 circles. 3 circles were of diameter 190 mm, second circle was of diameter 140 mm, third circle was of diameter 76 mm. But two additional circles were drawn to show the chamfer circles. Because after chamfering, if we observe these corners, that is this corner and this corner, from the top view we can see the chamfer circles. So two additional circles have been drawn to represent the chamfer circles. Now in the next step, we have to show these holes, that is the internal threading as well as the hole which is provided for inserting the head of the screw. Now if we observe these holes from the top view, they will not be visible. Now why they will not be visible? Because these holes are present inside the base plate, that is here internal threading has been performed. So these holes will not be visible from the top view. So if we observe this hole from the top view, we can observe 3 circles. First circle, which will represent the minor diameter, will be of diameter 4 mm. The second circle will be represent the major diameter, that is equal to 6 mm. So we have to draw two hidden circles, one for the major diameter, that is 6 mm, and one for the minor diameter, that is 4 mm, and the third circle which will be hidden, it will be of diameter 10 mm. So in short, we have to draw 3 circles in the top view that will be hidden. Before drawing the circles, we have to first project this center line in the top view, that is this center line in the top view. So now we will draw the center line in the top view also. We will project this center line. You can see I am projecting here. So we will project till here. So this is the center of this hole. So this hole which is having center here will have the center in the top view at this point. So I have projected this center line in the top view. So this will be the center of the circles. Now we have to draw here 3 circles which will be hidden. So the first circle, which will be a hidden circle, will be of diameter, you can see here. Now we will draw the first circle which will be of diameter 10 mm. We will select here circle and diameter. So the first circle will be of diameter 10 mm. You can see I will give a diameter here. So this circle will represent the hole for the head of the screw, that is diameter 10 mm. Now the second circle will be drawn to represent the major diameter of the thread, that is 6 mm. Now you can see if I give the dimension of this hole, it is what, 6 mm. And the third hole that will be drawn will represent the minor diameter of the threading. So it will be equal to 4 mm. Now we will give a dimension here. Now you can see this dimension is equal to 4 mm. So in all we have drawn three circles. One circle will be of diameter 10 mm and it will be a hidden circle. So we have to draw with the help of dotted lines. The second circle will represent the major diameter of the thread, which will be of diameter 6 mm. Again it will be a hidden circle. And the third circle will be of diameter 4 mm, which will represent the minor diameter of the threading. So in all we have to draw three circles in the top view with dimensions as 10 mm, 6 mm and 4 mm respectively. Now I am deleting these dimensions. Now the total number of holes which are present in the base plate will be equal to 3. Now you can see from this question, the stem is having total 3 holes at its bottom. So these 3 holes or similar 3 holes will be present here also. So in the base plate also we have to show 3 holes. So in the top view, if we observe this base plate from the top view, we can easily observe these 3 holes. So we have to draw the 3 holes in the top view also. Now till now we have drawn the top view only of the first hole, that is this hole which was visible in the front view. But in actual there are 3 holes present inside the base plate and 3 holes will be placed at an angle of 60° with respect to each other. At an angle of 60° with respect to each other. So first, sorry, they will be present at an angle of 120° with respect to each other. So now what we'll do, first we'll mark the center line of the other hole which will be at a distance angle of 120° from this line. So this is the center line of the first hole. Now we will mark the center line of the second hole. Now the center line of the second hole will be at an angle of 120° from the first. Now you can see I will mark first the center line. Now you can see this is the center of the second hole. This is the center of the second hole and the total angular distance between these two lines will be equal to 120°. Now I will give you the dimension also so that you can understand. The total angle between these two lines will be equal to 120°. Okay, total angle should be 120°. So now you can see this is the second center line. Now we will show the angle. We will check the angle. It should be equal to 120°. So you can see this is the center line of the second hole and it will be at an angle of 120° from the first one. Similarly, now we have to mark the center of the third hole. Again, that third hole will be at an angle of 120°. So this was the center of the first hole. Now from this line, we have to draw the second center line, which will be again at an angle of 120°. So you can see here. From this point, this was the first center line at an angle of 120°. Now we will draw the second center line again, which will be at an angle of 120°. Okay. Now the second line should be also at an angle of 120 degree. So you can see we have drawn the second center line. Now we will check the angle of the center line again. So from this line and to this line we'll check the angle. So the angle is equal to 120 degree. And if we check the angle of between these two lines, from first line and this is my second line, you can see the angle is equal to 120 degree. So we have to draw three holes, and the center of the three holes will be inclined at 120 degree with respect to each other. This is the first center line, this is the second center line, and this is the third center line, and all the centers at an angle of 120 degree from each other. Now we will draw the remaining two holes. For drawing the holes, we have to first mark the pitch circle. So pitch circle is nothing but the circle passing through the center of the hole. So this is the hole, center of the hole. So we have drawn a pitch circle. This is nothing but the pitch circle. Now this pitch circle is passing through the center of these holes. So again we have to draw similar holes and taking this as a center, and then again the hole taking this line, this point as the center point. So now we will draw the holes. Taking this as a center, first we will draw a circle, hidden circle. The circle should be a hidden circle. This will be a hidden circle of diameter 10 mm, first circle. Then again we will draw a circle to represent the major diameter. It will be of diameter 6 mm. And then again we will draw a third circle of diameter 4 mm to represent the minor diameter of the thread. So we have drawn the three holes, three circles to represent the internal holes and threading. Again, taking this point as center, we will draw the first hole which will be of diameter 10 mm. Then we will draw the second hole to represent the major diameter, that is 6 mm. And then again we will draw the third hole to represent the minor diameter of the thread, that will be equal to 4 mm.